Hi, everyone who's joined so far. We're going to wait a few more minutes. I have that it's currently 3:59, so I'll wait until 4:03 to begin officially. Hi, everyone who's just joining us now. Again, I have that it's 4:01. We're going to wait until 4:03 to get started as a few more people come in. All right. Hello, everyone, and welcome to the 2022 Rose Maguire Lecture. I'd like to start by acknowledging that Carleton University is situated on the traditional and unceded territory of the Algonquin Nation, and that we are benefiting from that even in this virtual environment. I'd next like to introduce Liz Klassen, who will be introducing the Greek and Roman Studies program before we get started on our lecture. Go ahead, Liz.
Hi, I'm the coordinator and advisor for the Greek and Roman Studies program, and we teach courses in ancient history, so you can learn about Alexander and Caesar, literature, where you can read Homer, Virgil, the dramatic artists, all kinds of people. Languages such as Greek and Latin, but also we have a linguist who teaches for us, who will do on occasion ancient Persian and other interesting languages. Archaeology, philosophy, religion, we teach a lot of different things. So archaeology is what I'm teaching this year, and as well as Latin. And in the archaeology minor, you can get the opportunity to dig somewhere else. So sometimes you can get credit for it. This year, because of COVID, you have to find a dig close to home. But usually you can get a letter of permission to go anywhere in the world and get credit for digging for 3 weeks or more. Another highlight of what we normally do in non-COVID times is to take students on a trip to a part of the Greek or Roman world. That could be Greece or Italy, but also we've been to Britain and Turkey. So the last time, I took students, it was to Rome and Pompeii. So that's a wonderful thing to do. We teach 4-year programs, 3-year programs. If you want to do a major, we've got a Greek and Roman Studies minor and an archaeology minor. So I would welcome anybody who's interested to email, maybe arrange a visit, and we would be happy to meet you. Back to you, Jackie.
Thanks so much, Liz. I'll next be introducing the Rose Maguire Lecture. The Rose Maguire Lecture in the Humanities was endowed in 2002 in memory of Rose Maguire. Rose Maguire immigrated from Ireland to Ottawa in the late 19th century. Her husband, Joseph Chilhuli, was a member of the Ottawa Police Service and rose through the ranks to Chief of Police, a position from which he retired in 1931. Her grandchildren, one of whom endowed the lecture, remembers Rose Maguire as, quote, a retiring, soft-spoken and gentle woman, unquote, who was beloved by her family. And last but not least, I'll be introducing our speaker. I know that many of you need no introduction to Kyle Harper, particularly those students in my Roman history class who have been reading some of his work. But here we go. So Kyle Harper is an economic and environmental historian who currently holds the GT and Libby Blankenship Chair in the History of Liberty and is full professor of classics and letters, senior advisor to the president and provost emeritus at the University of Oklahoma, from which he also graduated with his bachelor's degree. He received both his master's degree and his doctorate from Harvard University and has been a fellow at both Dumbarton Oaks and the Guggenheim Foundation. His publications are too numerous to list, so I'm mentioning only the books, Slavery in the Late Roman World, which won the James Henry Breasted Prize from the American Historical Association and was recognized with the Outstanding Publication Award from the Classical Association of the Midwest and South. From Shame to Sin, the Christian Transformation of Sexual Morality, which won the Award for Excellence in Historical Studies from the American Academy of Religion, and was also listed as a Choice Outstanding Academic title. The Fate of Rome, Climate, Disease as an End of an Empire, which has been translated into 12 languages and was first brought to my attention by a colleague who said, this is the most important book in Roman history that you will ever read. And finally, his most recent publication, Plagues Upon the Earth, Disease in the Course of Human History, which was published late last year and has already won the Prose Award for the best book in the history of science, technology, and medicine. We're so pleased to be able to welcome Dr. Harper to Carleton. Thanks so much.
Thank you. Can you hear me? Can I have a thumbs up? And you're seeing my screen. 2 thumbs up. Good. Thank you, Jacqueline. That is so kind. I'm delighted to be here. Thank you, Carleton. Thank you, the College of Humanities, and to the Greek and Roman Studies program. I can only endorse Liz's comments in the strongest terms that everyone should at least have a minor or one of their majors in Greek or Roman studies, both for the enrichment of your life and for your future success. It sounds like an amazing program. I wish I were there in person. I've been hearing about this lovely campus on an island and a river. And I hope that when things get back to normal, that I'm able to visit you in person someday. But we all live now in a world that's reminded us of the tremendous power of infectious diseases to upend our lives. And as a historian, that's something that interested me. I like to say there's a country song that I was country when country wasn't cool. I was writing about pandemics before pandemics were such an urgent topic again. And so I started writing a book about pandemics in the Roman Empire 7 or 8 years ago that came out in 2017. And as soon as I finished that one, I started writing a global history of the role that infectious diseases have played in the human past, right down to the present. And I think that's an important story. It's important for us as historians, but also for us as citizens to understand where we come from in order to understand the present. And so as I talk today, I really have one theme with two applications. And the main idea is that to understand pandemics requires the tools, the intellectual and conceptual tools of both the humanities and the natural sciences. And the two applications of that are both the past and the present. That is, to understand the history of the human species, we have to understand, we have to use the tools of both what we might think of as natural sciences, in this case, sciences like biology or microbiology, as well as the tools of humanists, the use of languages, the use of documents and archives that are often very difficult and challenging to use. And so I'm an advocate for and champion of a truly interdisciplinary approach to the human past. And so one thing I'll do is explore the ways in which understanding the biological reality of pandemic disease can help us understand the history of the cultures that we're so interested in my case, the Romans. And I'll talk about two particularly prominent episodes of pandemic disease using the tools of both the humanities and the social and the natural sciences. But another theme that'll run through this discussion is the importance of that in our own world, to understand the pandemic, COVID-19, but also the past, present, and future of pandemics by bringing tools that are both technical, medical, scientific, as well as humanistic. And to make that point, I want to start not with my ancient Romans, but with a little more modern example. And so in 1806, President Thomas Jefferson wrote a letter to Edward Jenner, the country physician in England, who more than anyone else discovered vaccination. He realized that you could intentionally expose people to cowpox and that it would confer resistance to what was then the most deadly disease in Western Europe and one of the most deadly diseases in the world, the viral disease smallpox. And I think Thomas Jefferson was absolutely correct to write in the grandest terms to Jenner that medicine has never before produced any single improvement of such utility. In other words, what you discovered, Edward Jenner, is the greatest medical discovery of all time. Future nations will know by history only that the loathsome smallpox has existed and by you has been extirpated. I think that's a true statement that vaccination is the single most important biomedical discovery in human history and has really liberated us from a world where we were mostly helpless against a class of particularly, but not only viral diseases. And yet the other point I would make about this is that just because Jenner discovered vaccination, smallpox didn't go away immediately. Both Jenner and Jefferson actually foresaw a future in which smallpox would not exist. But it took a long time for that future to become a reality. Smallpox is the only human disease that's been completely eradicated. There are a few others that are in sight, but it's still the only human disease that we've completely got rid of. And it took almost 2 centuries. It took even decades in Britain and the United States. The United States didn't get rid of smallpox until the early 20th century. And globally, it took even longer. Why did it take so long? I think this is a point that's resonant in our own experience of COVID-19, which is that pandemic diseases are not just biomedical problems. They're social problems, they're human behavioral problems that are best addressed by a combination of both scientists and humanists, people who study human behavior, human systems of meaning, as well as people who are very good at doing things like designing vaccines. In our own times, we've seen the development of multiple highly safe and effective vaccines. And yet the COVID-19 pandemic has continued to drag on. And the reasons are not so much because we don't have the biomedical or scientific understanding, but rather we've not given enough attention to understanding the social and behavioral aspects of confronting a pandemic disease. I think history is one of the ways in which we can develop a deeper understanding of human social and behavioral reactions to pandemic disease. So it's always worth remembering that we live in a time that is in many ways very privileged relative to the past. Here's a chart that I like and I think says as much as possible in one chart about the radical differences that divide us from pre-modern, in fact, from all ancient and pre-modern societies. On the top are the little circles, those are the countries around the world today, and you can see that life expectancy ranges from the 50s to the low 80s. And that people tend to have larger incomes. On the bottom axis, the x-axis, you can see on a log scale a plot of per capita income. So modern societies are globally, on average, relatively wealthy and long-lived relative to all pre-industrial, pre-modern societies. We also, in contemporary societies, die mostly of not infectious diseases. So even in COVID times, when an infectious disease has risen again, most people die of cancer, organ disease, cardiovascular disease, other chronic conditions, not because of infectious microbes. By contrast, and you see on the circled X's, that's the 5 continents where we have some data. In pre-industrial times, most people were extremely poor and most people had low life expectancy because most people died of infectious disease. So we live in this very different world. And in some ways, that's essential to remember when we think about the history of pandemics during COVID-19. There are certainly similarities between the COVID-19 pandemic and pre-industrial, pre-modern experiences. We have a novel biological agent, in this case SARS-CoV-2, that spreads through a susceptible population, that takes advantage of the interconnections of our society, that causes a lot of sickness and death and destabilizes our society. That's a pattern that is recurrent throughout human history. At the same time, when we, for instance, as we were about to go back to the Roman world, we are entering a structurally very different kind of world. Again, most people in antiquity die of infectious diseases at all times. People have very low life expectancy. And the ultimate reason why is because they don't have the kinds of tools that we have. They don't have what we call germ theory. So when we're talking about Greek or Roman accounts of infectious disease, most of these writers don't have the same concepts that we have in the modern world, where we know that bacteria and viruses exist and cause disease. They think in totally different ways of imagining the human body and human societies and the environment, and don't think that there are tiny little invisible agents that cause disease. We've discovered that in modern times. We've developed powerful responses to that, like vaccines, antibiotics, other kinds of public health measures like clean water that we know protect us from dying of infectious disease. So they weren't capable of developing rapid biomedical responses when they were confronted by new biological threats. And of course, in the ancient world, they didn't have Twitter, so they did have a few advantages on us. Despite these enormous differences between our world and the world of the past, I think that it's a point of connection. We've now lived through a traumatic pandemic, and the experience of that pandemic, I think, can help us understand ancient societies more empathetically and more deeply than we have before. When our ancient sources tell us about the pain of things like separation of families during mortality crisis, disruptions to the kind of ordinary rituals of burial and funerals, the kinds of social mistrust that are often engendered by biological crisis, and the kind of unequal social effects of pandemics and the ways that those reverberate throughout societies. We can really read those sources, I think, in a different way, having had our own direct experience of a pandemic. So I'm a historian of the ancient past, but I think it's helpful to bring to our study of ancient texts, even with the very different ideas about the world, some of our basic knowledge about infectious disease. And so I'd start with some really basic question. What is an infectious disease? I've used that term a lot. It's any state of impaired health that's caused by an invader, usually a microbial invader. They come in all kinds of different biological categories, like viruses, which cause COVID-19, the SARS-CoV-2 virus, also cause other major diseases like smallpox and measles, AIDS, yellow fever, and so on. Bacteria that are single-celled organisms that are very primitive, don't have an organized nucleus. Most bacteria out there in the world are actually nice. Most of them are harmless, but a few of them give bacteria a pretty bad name. They cause some pretty nasty human diseases like bubonic plague, cholera, tuberculosis, which is probably the biggest killer of humans of all time, and other gastroenteric diseases. Protozoa that cause diseases like malaria are single-celled organisms that are a little more like one-celled animals, and are really devastating parasites and cause a small number, but a very significant human diseases like malaria. And then worms. Humans are infected by a variety of worms like hookworm, roundworm, whipworm, or what you see here, a worm that causes a disease called schistosomiasis. It is a major burden on human health. So humans have lots of parasites. We have lots of enemies. They all have one problem in common. How do I get from one host to the next? How do I get from one human body to the next? This is in some ways the most basic evolutionary problem that any infectious microbe has to solve. And they've figured out just about every way to get from one host to the next directly by skin contact. Some of them use intermediate vectors like mosquitoes that helpfully give pathogens a ride from one host to the next. And mosquitoes are one kind of vector, and they are responsible for the transmission of a number of really important human diseases. A large number of microbes take advantage of what's called the fecal-oral route, meaning that they're microbes that infect the intestines and are passed out in waste matter, and then are ultimately find their way into food or water supplies, usually water, and into the mouth of the next victim. These are responsible for a huge number of infectious diseases and cause a major burden of morbidity and mortality in both the past and the present. Of course, when we think of infectious diseases, we may think most directly of respiratory diseases. COVID-19 is a respiratory disease. These are diseases that pass directly from the respiratory tract of one victim to the next by coughing, sneezing, and so on. And then sexual transmission. Sexual transmission is actually fairly hard to evolve. There are only a really small number of sexually transmitted diseases, but they cause a major burden of disease like AIDS, syphilis, and so on. So every way that they can get from one host to the next, there's some microbe that has figured it out. It's important to understand too that microbes that cause disease are moving around constantly in nature. And as we learn more and more about infectious disease, are very susceptible to infection with COVID-19. So human health is part of the bigger world of animal health. Some microbes are very evolutionarily adapted to humans, and in fact, some can only transmit in human populations. Many others move easily between different species of hosts. Diseases that transmit mostly among animals we call zoonotic, just diseases that are reliant on animal hosts. And finally, on this line of thought, a basic question: what is, in our terms, a plague? To put it more scientifically, what is an epidemic? The CDC, the US's National Public Health Agency, defines an epidemic as an increase, often sudden, in the number of cases of a disease above what is normally expected in that population in that area. So the CDC defines an epidemic. It's simply an outbreak, a big episode of sudden infection that spreads through a population. In other words, epidemics happen when a pathogen infects a susceptible population. And this is why diseases are always both biological and social events. There's no separating these two in the instance of an epidemic. That is that to have an epidemic requires both the microbe, the pathogen that causes disease, but also potentially vectors or hosts like the human body. And ultimately, it infects a population. So there are always social dynamics that have to do with how healthy is a population, how stable is a population. War and famine are often very important triggers for outbreaks of disease, and how connected is a population. We've learned from COVID-19 that epidemics spread easily where people live in dense and interconnected areas. So infectious diseases or epidemics are interesting because they're always both biological and social phenomenon. So I'm interested in the big history of infectious disease. And one of the big patterns is that human history is one of the driving forces in the evolution of our infectious diseases. So the human disease pool, all of these infectious diseases that I've named so far, like smallpox, measles, plague, syphilis, AIDS, yellow fever, tuberculosis, malaria, these are all, in a sense, products of human history. In fact, none of those diseases existed 100,000 years ago. All of those diseases are relatively young in evolutionary terms, and they're a product of human history and the ways that humans have developed technologies that have changed the way that we exist in the world, increased our numbers, increased our cities, increased our connectivity. And so every technological advance throughout human history, whether it's the invention of farming, the domestication of horses, and the rise of large states and empires, the rise of massive transoceanic transportation, the rise of fossil fuel energy, even in our own day, the jet airplane that connects us. Every time that human society has made a technological advance, it's impacted the kinds of diseases that evolve to take advantage. One of the big themes in the big history of infectious disease is human connectivity, or in other words, globalization. We sometimes think of globalization as a very modern phenomenon, the interconnection of our world by telecommunications that lets us follow everything that's happening in the world on social media and on internet delivered news. The rise of jet travel that lets us move easily anywhere in the world. The rise of sort of transnational global capitalism. That means you can go to a McDonald's in almost every country in the world. We think of that as globalization, and it is. But it's only the most recent chapter in a very long history of the story of how human societies have become more and more globally interconnected. This is a story that goes back thousands of years, and we can think of it as having different chapters, like the domestication of the horse was one factor in rapidly increasing the amount of connectivity between human societies. The rise of large-scale empires that also fostered long-distance connections, communications, and trade. The rise of global trade systems, particularly in the late Middle Ages, and then the crossing of the Atlantic by Christopher Columbus that sets in motion modern globalization. The rise of new fossil fuel-driven transport technologies like the steamship and railroad and the jet plane in our own day. So as human societies become more interconnected, it allows diseases to transmit further and faster than in the past. Now, as a historian, I think that's the big background to the phenomenon that is so apparent in Roman history, which is that the Roman Empire undergoes a series of major pandemics. So I defined an epidemic, which is a sudden increase in a disease. Epidemics are pretty normal in human history. When you have infectious diseases, there's always a lot of change and dynamism in the death rate. But pandemics are something a little bit different. A pandemic is really just a huge epidemic. It's when there's a sudden disease outbreak that crosses between different regions. So the COVID-19 is a pandemic because it's a disease outbreak that didn't stay in central China. It became a transcontinental, a truly global disease outbreak. Pandemics are not exclusive to the modern period. And if we explore Roman history, it's apparent that in the high and later Roman Empire, the Romans experience a series of pandemics, simply of sudden disease outbreaks that strike over a very large territory between different regions. So I've examined the sources as comprehensively as I possibly can from about 200 BC down to the 160s, and there's no evidence for true pandemics for a time period of well over 300 years in Roman history. There were certainly major disease outbreaks in the city of Rome, maybe even in regions like Italy, but there's no attestation of really massive interregional disease outbreaks until the 160s, when an episode called the Antonine Plague that I'll talk about hits the Roman Empire. Then about 3 generations later, there's another pandemic event. I won't spend as much time talking about this one, but it's known as the Plague of Cyprion and strikes in the Roman Empire in the 250s and 260s. And then there's a lull in one of the most well-documented periods of antiquity in the the 4th and 5th century. There are, again, a number of major disease outbreaks that are fairly localized before what I believe was quite certainly the most significant disease outbreak in the ancient world, the first plague pandemic that starts with a disease outbreak in the 540s AD in the reign of the Emperor Justinian, and thus called the Justinianic Plague. I'm going to talk about the first and third of these as historic examples of pandemics, where we can learn about the history of the human experience with infectious disease, but also as historians, where I think it's exciting because we're learning a lot about these events, partly because historians are more interested in the environment, they're more interested in infectious disease, but also because we're learning more about infectious disease and more about the history of infectious disease through modern technologies and the study of the microbiology of the pathogens themselves. So we can approach these in an interdisciplinary way, bringing to bear the tools, concepts, and evidence of things like genetics to help us understand these diseases. Let me just give a thumbnail sketch of these 2 events and why I think they're so interesting. The Antonine Plague is so called because it strikes in the 160s at a time when the Roman Emperor Marcus Aurelius belongs to the Antonine dynasty and is thus called the Antonine Plague. Some of you may have seen the movie Gladiator. It's that emperor. He's one of the good emperors, supposedly, and certainly rules the Roman Empire very near its absolute height of power, prosperity, and ultimately this new plague arrives on the scene. The sources that we have, in contrast to the 300 years or so prior, are uniformly insistent that this was a very serious disease outbreak. So we have inscriptions, for instance, a Roman senator who says this was a great pestilence. One of the greatest doctors of the ancient world, Galen of Pergamum, a Greek physician who, along with Hippocrates, is one of the 2 most famous medical writers from the ancient world, happened to be alive during the outbreak of the Antonine Plague, and references it numerous times throughout his extensive corpus of medical writings. Another text that's probably not by Galen talks about this pestilence that, like a foul beast, rampages over cities and destroys them. We have numerous inscriptions of people trying to stop the plague by appeasing the god Apollo. Remember, they don't know the scientific explanation for plagues, and they think of it in religious terms, and principally as the anger of the god Apollo. And so we have a number of inscriptions that refer to cities trying to appease the god Apollo by asking his temples, what do we do to stop this? And supposedly even the Emperor Marcus Aurelius on his deathbed says, why weep for me rather than for the plague and those whom it killed. So even later historical sources remember this. A 4th century historian remembers the Antonine Plague as one of the big ones. So we really know, even from the most conventional sources, that there was something big going on here. The little markers are things that give us some hint that the plague may have reached that far. And so, while there are a lot of questions about how far the plague went, this episode stands out dramatically from the background of ordinary disease outbreaks in sheerly the geographic expanse of this outbreak. We are learning a lot, but also still have a lot to learn about this disease outbreak. And I think a lot of the exciting work right now is trying to figure out what triggered this. Was there something, we call it endogenous, something inherent in Roman society and economic development? Was there overpopulation? And this was a kind of inevitable crisis that came about because there were simply too many people? Or was it exogenous? Was there some random event outside of the trajectory of Roman social and economic history? Was there climate change? And I don't argue that, but I think it's a plausible story that some other very good historians do believe. And I think we'll learn more about whether that's a plausible story. To me, the most likely trigger, and I would say that COVID-19 has, I think, made this more intuitive for us, was the evolution of a new biological agent. So the emergence of a pathogen that was able to sweep through a population that didn't have any prior exposure or immunity to the disease. Now, the problem is, and COVID-19 is a good example because it's had different effects around the globe, but the one unifying thing we can say is that it's a nasty virus that's extremely contagious and very well adapted to transmitting in humans. And so there's a really fundamentally biological trigger. The problem with the Antonine Plague is we don't know what that trigger was. We don't know what the biological agent was. Historians have been and still are debating this. It used to be thought that it was smallpox. For various reasons, that's not possible. It's possible that it was an ancestor of smallpox, but at present, we don't actually know what caused the Antonine Plague. We may learn if we're able to identify archaeological DNA that could identify the pathogen, as is the case with the Justinianic Plague that I'll talk about in a moment. The demographic impact is highly debated because we don't, in ancient societies, have the same kinds of reliable government statistics that we have for more recent times. And so estimates have diverged widely. For myself, I've said probably somewhere in the range of 8 to 10% of the imperial population as a whole. That's higher than some estimates, lower than some estimates, but I think would be a really profound demographic shock, a massive loss of life that would account for the evidence that we see. And then, of course, as historians, we like to debate, what did it matter? These were societies where a lot of people died, even at the best of times. So were there really economic and political effects? One thing that I argue is that we need to try and understand the Antonine Plague in a geographically bigger sense. Where did it come from? It may have come from outside the Roman Empire, either from the Red Sea, where the Romans have extensive trading links that connect them with the Indian Ocean world. It could have come from Mesopotamia. So we know that the Roman armies were deep inside Parthia in Mesopotamia and probably certainly caught the disease there and helped disperse it throughout the empire. It could have traveled over the Silk Roads. And so there's a lot of interesting work, and we need more work on China and possible links with nearly contemporary outbreaks in China that are very well attested, but we don't really know for sure whether they were caused by the same pathogen. So there's a lot to be learned still about this well-known disease outbreak. And particularly, historians will keep exploring what can we learn about the number of people it killed and how much it may have affected the Roman Empire. These are very tricky questions when you don't have government statistics. And so historians use things like proxies from everything from army diplomas, which all of a sudden stop right when the Antonine Plague breaks out. These discharge receipts that soldiers get simply dry up. Maybe because the army didn't want to let anybody out, maybe because the state was just so dysfunctional. It's not a slam dunk argument, but it's certainly an important pattern. Historians are increasingly using really cutting edge scientific tools like Greenland ice cores that give us insights into the level of pollution. And you can see that the Antonine Plague, as Andrew Wilson and his team have pointed out, coincide with a sharp drop in the amount of pollution that's reaching Greenland, implying a breakdown of Roman metal production, silver mining, and coin production. And then, of course, we use archaeology. If you look at the blue line, this is relatively well-dated evidence for settlements and trade in Italy, really in the Roman hinterland. This is the new BSR survey data, if you're interested. You can see what's important is that something major happens in Italy in this time period, the 160s, 170s. Doesn't mean the plague had to be the cause, but it's certainly suspicious that this is so coincident. So historians are still very much in the process of trying to assess what caused this plague, what were its ramifications. It seems to many, myself included, to be part of a really major rupture in the course of Roman history. So the Roman Empire was on a trajectory of growth, and in many ways was a kind of dominant superpower down into the later 2nd century. And the Roman Empire doesn't fall apart in the course of the Antonine Plague, but it's a far more difficult job for the Roman Empire to maintain the same level of dominance. And there seem to be major social and economic consequences. The plague is a part of those important changes. There's a big contrast with the plague of Justinian, starting with the fact that we know what caused it. And we know what caused it because of interdisciplinary teams doing what's called archaeogenetics or paleogenomics, the study of ancient DNA. So we now have identified the pathogen that caused this plague outbreak. It is a bacterium known as Yercinia Pestis. This is not just any old bacterium. It is the single most destructive bacterium in human history. That is, that it is responsible for the most destructive outbreaks of epidemic disease that are known to human history. Most famously, the outbreak of the Black Death in the 1340s, which was also caused by the same biological agent, the bacterium Yersinia Pestis. Y. pestis is in a league of its own, and we now know with 100% certainty that it arrives in the Mediterranean world of the Roman Empire in the 540s and stays for nearly 2 centuries. I think we should call the outbreak in the 540s the Plague of Justinian, named after the ruling emperor, and the broader series of outbreaks that lasts for over 2 centuries, the First Plague Pandemic. We can compare this with the Second Plague Pandemic. We know, for instance, that the Black Death in the 1340s was an outbreak of bubonic plague, but that it wasn't the only outbreak. In fact, one of the reasons why it's important is because it's part of the Second Plague Pandemic, a recurrence of outbreaks on average every 10 to 12 years that lasts, in this case, for over 3 centuries in Europe and continues to be the most devastating epidemic disease from the very beginning of its appearance in Europe in the 1340s down to its disappearance in the 17th century. My own work as a scholar is currently focused on Italy and the question of this bigger phase in which this disease becomes endemic. And I'm interested in what can we learn about a society that has to adapt when a terrible new pathogen becomes part of its disease pool for a time, as it seems that COVID-19 is very likely to be. Let me say a few things about the biology of plague, because I think as a historian, it's important to understand what makes this disease different from others and why its appearance should be considered such a dramatic event in human history. Plague is a bacterial infection, and it has 2 really important features to start with. One, it's an animal disease. It's a disease that circulates permanently in wild rodents like marmots and gerbils and ground squirrels of different kinds. And it cannot transmit sustainably in human populations. So plague is a disease that always has to go back to the animals. And when we have a human outbreak, it's always a crossover event in which an animal disease is temporarily infecting humans. And I'll come back to that again in a second. It's also distinct in that it's a vector-borne disease. Vector-borne diseases are very nasty. We can be thankful that there aren't more of them. And the reason they're nasty is because they have figured out how to navigate 2 immune systems, the host immune system and the bug immune system, in this case, fleas. And plague is a vector-borne disease that transmits very easily by flea bite, when fleas bite one infected victim and then go bite an uninfected victim, but introduce the bacterium into the new host. Vector-borne diseases can be very efficient. And unfortunately, plague is very, very good at using the flea as a mechanism to transmit. The plague bacterium has genes that sort of turn the flea into a kind of activate a kind of feeding frenzy in the flea that make it really, really devastatingly good at spreading the plague. The upshot of this is that plague is actually a very ecologically complex disease. And so when we're thinking about a human outbreak, in this sense, it's not like COVID-19, which is really now just spreading in human populations. Plague is always moving between wild animals and animals that live close to humans, commensal rodents, that is rats that live in and around human habitations, historically like the black rat, which probably is a crucial link in the ability of bubonic plague to become so devastating. So a plague outbreak is really a multi-species event in which the bacterium gets from its wild host into black rats and then is spreading quickly in rodent populations and continuously leaping over to humans. Plague can spread between humans. I said not sustainably, but during big outbreaks, humans may have been coughing up the disease. It can get into your lungs and may have been transmitting it directly from human to human. And some have even thought that human ectoparasites, so lice in particular, may have been important in spreading the disease. It's a really complicated disease in the way that it spreads. Bubonic plague is a really horrible disease. It's very deadly. It takes different courses in different victims. The most notable and notorious course is bubonic plague, when little hard balls that are infected lymph nodes form in the neck, the armpits, the groin, or the knees. Plague also gets into the blood and causes septicemia. It can get into the lungs and cause pneumonic infection. Without antibiotics, the good news is if you get plague today, get to a hospital, get antibiotics ASAP. Unfortunately, in pre-modern times, they did not have antibiotics, and case fatality rates would have been enormously high. So probably at least 2/3, 3/4 or more of everybody who gets plague in the ancient world will die. Most of them will get bubonic plague, and a subset will get pneumonic plague. Some way, somehow, and historians are very interested in that question right now, bubonic plague unambiguously and dramatically appears in the Roman world of the Eastern Mediterranean in the year 541. We have several eyewitness accounts, very different in their worldview, from the Syriac churchman, John of Ephesus, to the classicizing, one of the last great Greek classicizing historian, Procopius. They both emphasize the arrival of the disease in Egypt and its transmission around the Eastern Mediterranean, including the following year, its arrival in the capital of the Eastern Roman Empire in Constantinople. I won't read this much text, but only give you teasers here in the hopes that you will go and study these. We actually have a lot to learn about these accounts. One of the things that strikes me about these eyewitness accounts are the ways in which they cohere, even though these two people didn't rely on each other. They described the appearance of a disease that overwhelmed this city and this society, including the ability of the society to bury its dead. And they both described the urgent efforts to build ditches and then ultimately to shuttle bodies out on ferries in order to reduce the number of corpses that were laying around. So the appearance of the disease in Constantinople was absolutely shocking. But one of the big challenges we have in the history of the Justinianic Plague and the first pandemic is that when we rely on these kinds of sources, which have strengths and weaknesses, but the ultimate weakness is simply that their perspective is limited, their frame of view is highly limited. And so we know relatively a lot about the outbreak of the disease in Constantinople, and we know, sadly, close to nothing from eyewitness testimony to the outbreak of the disease in some regions, particularly the Western Mediterranean. So I mentioned my interest in Italy. For the outbreak of the first pandemic in Italy, we know it arrives in the following year, 543. We have one sentence describing it. The challenge is that we don't have other accounts of what's going on in Italy where we would expect to find it. The challenge is that we simply don't know what's going on in Italy, potentially because of the disruptions of war and plague mortality itself that have rendered the record so inadequate for us to understand. So what was going on outside Constantinople? We know more about the Eastern Mediterranean than the West. We know more about cities than about the countryside. This is one of the exciting areas where we're learning truly new things, where big questions are starting to be answered. And I've mentioned the field of archaeogenetics that identify the pathogen responsible for ancient disease outbreaks and can also help us resolve some of these most difficult questions, like, did the plague really reach Western Europe and the Western Mediterranean? Did it really affect places outside of the big cities like Constantinople? And there's still much to be learned. Here's a major paper that came out in 2019 with a big team led by Marcel Keller and Maria Spiru, who were then under the supervision of Johannes Krause in Jena, now at Leipzig. But this is one of the most remarkable studies of the first plague pandemic so far. And what they found were 8 new sites adding to 2 existing sites where plague bacteria DNA from the first pandemic was recovered from the skeletons of people who died in this pandemic. And one of the most important findings is that this plague spread far to the west, and that it clearly was able to reach villages, places that are far off the major trading routes. And so this gives us increasing reason to infer that the plague pandemic was able to affect populations, not just in the highly urbanized and interconnected Eastern Mediterranean, but far more broadly. I'm interested, though, not just in the first outbreak, but in the long history of the pandemic, the recurrent outbreaks. One of the really interesting open questions is, where does the plague go between outbreaks? What kinds of animals is it hiding in? How often does it come back? How is it moving? Here's a picture I've made of some of the known outbreaks. Each of these little dots is an attested outbreak in the written record. And there's been far less attention paid to these later outbreaks. In fact, 90% of the historical attention, at least I would say, has focused only on the first outbreak in the 540s, whereas we have an enormous amount to learn about the shape of the first pandemic as a whole. And some of these later outbreaks seem to have been quite significant. And there's one that I'll just use as an example. In the year 565 in northern Italy, we have a historian, Paul the Deacon, who's using a contemporary text, who was an eyewitness to this outbreak that we've since lost, describes a very great pestilence. And just to point out how much we have to learn, this outbreak has been uniformly misdated. It very clearly dates to 565, although if you read every historical account, it says 568. That's pretty significant because something big happens in Italy in the late 560s, the arrival of the Lombards. We know from this passage that it was bubonic plague. We don't yet have the DNA from this outbreak, but the description of the disease itself by our historian Paul describes clearly bubonic plague symptoms. We know that it was traumatic, that it struck in towns and countryside alike, and that it was a major shock to the people who lived in Italy at this time. And we know that its consequences may have been significant. In fact, this account that ultimately goes back to an eyewitness tells us that Italy was taken over by the Lombards, who are Germanic people who certainly set up a kingdom in much of Italy, northern Italy, in 568 and the early 570s. And this is an eyewitness who tells us that the Lombards were able to take Italy in part because the Romans didn't have the force or the strength to resist because of the giant pestilence that had struck just a few years before. So that's an eyewitness account. It's a written account. One of the big challenges is it's our only source for this outbreak, but it's a very vivid source. And it's one that I think we can read empathetically. It describes the trauma of mass death, the separation of families in time of sickness, the inability of a society to continue its normal rituals of grieving and mourning. And the lasting effects of that have left their traces so clearly in this chronicle source that happens to come down to us. And ultimately, it tells us that the challenging thing for us as historians to understand. But here's a contemporary account that connects all the dots for us in what I think is a really powerful way. So we still have an enormous amount to learn about the first pandemic. I focus on this in part because it's where my own interests and my own scholarship is right now, to try and understand the long first pandemic as a time period when societies had to adapt to the repeated appearance of this truly singular disease that was responsible for the largest scale mortality in human history that's well documented. So I'll close with these two thoughts, that understanding this history, how diseases emerge, what are the human factors, how diseases come to stay, how they become endemic, how societies adapt to the kinds of changes that are necessary when a new disease appears, is not something that we're going through for the first time. And so I think historians, among others, have an important role to play in deepening our perspective as we think about plagues as both biological and social events. And we think about public health and medical responses to plague as something that requires both biomedical, scientific expertise, as well as social, behavioral, and humanistic expertise. And then I am a scientific historian, but I still think that even interdisciplinary history has an important humanistic role to play. And I think in this case, hopefully one lesson that we take away is that diseases are a really important and fundamental part of the human past. Thank you very much.
All right. Well, thank you so much.
Please tell me I wasn't muted that whole time or something.
No, you weren't muted that whole time.
Okay. Okay. It was so quiet.
We would have told you. I promise.
Okay. Whew.
Thank you so much for that magisterial talk. And I don't use that word lightly. That was a fantastic journey through not only a lot of Roman history, but also a fair amount of biology that I'm sure everyone in our audience will appreciate. And I'm sorry to say for myself that I think I'm going to have to go back and re-record my lecture on the Lombard takeover of Italy.
Ah, good.
Since I said the somewhat older view that it has to do with Narses and his behavior as exarch.
Those are not totally incompatible, though. He may have been playing both sides a little. So I don't have to totally rewrite.
I will have an addendum video.
Good.
But I do want to invite our audience who have already started to use the Q&A to ask questions to please feel free to ask more questions. If you're looking at the bottom of your Zoom screen, for people who are less familiar with Zoom, there should be a sort of Q&A box. You can click on that and type in questions, and we will get through as many questions as we can in the next half hour and a bit. But I want to dive right into some of the questions that we've already received. So our first question is about the role of the Pax Romana and Roman Empire as a vector itself of spread. Can the reason that this disease spread so widely be attributed to the Pax Romana?
That's a great question. And I would say in some ways, the main thesis of my 2017 book, The Fate of Rome, is to say yes, and here's why. And so if you go back to one slide that I had, and one of the ways in which we sometimes think about what causes pandemics is sometimes framed in terms of, is it the kind of breakdown of the economy? So it's kind of Malthusian overpopulation that leads a population to be poorer and makes it susceptible to disease? Or is it something totally outside the socioeconomic system? So is there like climate change that can trigger disease outbreaks? Both of those are plausible models. But the one that I'm going for, which doesn't have to be totally incompatible with either of those really, is that it's not just the breakdown of an economy and a society that can contribute to the outbreak of a disease. In some ways, it's actually the success of an economy and a society that can make it more susceptible. And so the Pax Romana is what we use to refer to the 2 centuries or so of Roman peace, meaning that inside the empire, there's a relatively long period of basic demilitarization that causes the population to grow. Trade clearly benefits. The Mediterranean's pretty interconnected. Urbanization is important. So if we mean by all of those things, the Pax Romana, then yes, I think it does make the Romans more susceptible to the introduction of a novel pathogen, a new germ, and also to the transmission of a new germ. So, we think of the Romans and we think of the road network. We think of the Romans and we might think of the big grain supply system that's bringing grain from North Africa to Italy. All of those forces of connection that also go along with urbanization make it easier for pathogens to spread. And so the Antonine Plague may be a good example that I think it probably came from outside the empire. We won't know that until we really get the pathogen, but it could have been in fact, the trade networks. We know that the Romans and the Pax Romana have a huge trade system that brings spices and silk, all of these kind of consumer goods from outside the empire into the empire. That means that there's connectivity, there's interaction, and where there's interaction, diseases are going to take advantage. So in a sense, I would frame the Antonine Plague as a very good example of the ways that connectivity and paradoxically the kind of relative success of an economy in promoting trade and urbanization can give diseases an opportunity to take advantage of us.
Thank you. I'm going to now try to combine 3 questions
Okay.
into one. So hopefully the first question will be a good opener. But we have several questions on the role of various different diseases in human history. Diseases that specifically can be related to climate variation, viral diseases that cause pandemics in the history that you've studied, and or diseases which other diseases which lay dormant for centuries and then could reappear.
Okay, so I got climate change, reappearance. What was the middle one?
And viral.
And viral. Okay, those are all big questions. The relationship between climate and disease is a huge and important question, and I'll just say a couple things about it. One, there is a connection. I mean, diseases are part of human health, animal health, environmental health, and 2, that is less well understood than it needs to be, than you would think or hope. There's a ton of research on climate change and infectious disease going on right now because of the urgency of understanding in our own world where there's rapid anthropogenic climate change. What is that likely to mean for infectious diseases? And the reality is there's some good insights, but there's still a lot to be learned. The reality is probably that climate change will affect human health and infectious disease in a lot of different ways. It'll affect humans directly. So climate will affect human societies. It'll affect, drought and weather extremes that'll trigger conflict and migration. That's probably one of the most important ways in which climate change is going to affect infectious disease, is through affecting human societies. But there are other ways as well. For instance, I've talked some about diseases that depend on vector-borne transmission by mosquitoes. Mosquitoes tend to be relatively environmentally sensitive. So this is one of the things that makes them a little bit different from black rat fleas that are pretty able to go everywhere, almost. A lot of mosquito vectors are very particular. They has to be warm usually. It's why a lot of diseases are so-called tropical diseases, because the mosquito vectors that transmit them often can't live outside of the tropics. Well, if global warming increases temperatures on average, then the range of important mosquito vectors is going to be larger. So that's another way in which climate can drive infectious disease changes. This all matters for the ancient world, where it actually even gets even harder to know what the links are. But I'll just mention one very interesting example, and hopefully there may be undergraduates or grad students who can go on and be the ones who figure out some of these big questions. But the Justinianic Plague starts in 541. That happens to be a moment of extreme short-term climate change caused by a series of volcanic eruptions. In 536, there's a major volcanic eruption somewhere in the northern hemisphere. The sun disappears for over a year. Certainly the harvests fail. People would have been starving. People would have been migrating. People would have been fighting. Rodent populations would have been affected by this. And then in 540, 541, there's an even bigger volcanic eruption. So right when the Justinianic Plague happens. And these are not just little volcanic eruptions, they're huge ones that cause the whole planet to get cooler. The 540s are the coldest decade in the last 2,500 years. And we really don't know how that's related to the Justinianic Plague. It's a big question. There are lots of possible different mechanisms. Some of them have to do with rodents. Some of them have to do with humans. Were we more hungry and susceptible? That's probably part of it. But we really don't know the relationship between the climate and the outbreak of the Justinianic Plague. So it's a really interesting conjuncture. It can't be coincidence, but we don't know the mechanism. So climate and disease is a big, interesting area. Then there's a question about viral diseases. I mean, viral diseases are come in all shapes and flavors. They cause gastrointestinal diseases like rotavirus, but they particularly important range of viral diseases are respiratory. They evolve very quickly. This is one of the characteristics of viruses. They're tiny little passive particles and not even really alive that hijack host cells. They evolve very, very quickly. So they're particularly, and they've been really important through history. We now think that measles was around in the classical world. Is found in antiquity, and viruses have really taken advantage of human population growth in modern times. It's why the coronaviruses have been such an important family of viruses. There are 7 of them that infect humans. Most of these are pretty recent in the last 115 years, 125 years. So, so viruses, cause some of our big diseases. And what's tricky about viruses is that as you know, the therapeutics are difficult. It's relatively hard to treat viral diseases, although that's coming along quickly. And that's going to be one of the benefits of COVID-19 is there's a ton of money and research effort going into viral therapeutics. But viruses can often be controlled by vaccines. And so vaccines are particularly important because they're in some ways our only really, really effective tool against a range of viral diseases. Whereas bacterial diseases can have vaccines, but also can have pharmaceuticals that antibiotics that treat people who have a bacterial infection. So viral diseases are really important, and they're probably only going to continue to be really, really important. And then there was a third dimension. There's climate, viruses, and I was trying to remember.
And other diseases that have lain dormant for centuries and come back.
Yeah, I'm a little bit skeptical of this. You'll sometimes see headlines that the permafrost thawing may cause smallpox or some of these other diseases to come back. I don't know if that's what someone's asking about, but it's possible that they could be viable. I'd be much more worried about deforestation and human interface with wild mammals like rodents and bats that carry a huge number of diseases that seem to be able to adapt to us than dormant diseases coming back. But what I would say matters is the ongoing evolution of diseases that we may think are sort of under control, but that may be temporary. And the big and obvious example is tuberculosis, which is a bacterial respiratory disease that still latently infects a fourth of the human global population. There are 10 million disease cases of it a year. Before COVID-19, it was the deadliest pathogen on the globe. COVID-19 has temporarily taken it over, but tuberculosis isn't going anywhere. It's going to be right back. So tuberculosis never actually really went away. It was brought under control in wealthy societies. And it's increasingly evolving antibiotic resistance. And so drug-resistant, extremely drug-resistant tuberculosis, where we have very, very few remaining pharmaceuticals that can treat patients, are a really scary thing. So I think that's a much, if you don't want to sleep well at night, read about drug-resistant tuberculosis. But that's probably a bigger threat than other kinds of dormant diseases.
Right, thank you. So moving on to our next question, which is, I'm curious about the degree to which the kind of work you are doing, that is examining historical accounts of disease with an eye towards contemporary situations, might have been undertaken by the ancient writers themselves. For instance, did writers who gave accounts of the Justinianic Plague refer to and perhaps learn from things like Thucydides' account of the Athenian Plague? And did Roman writers like Galen use older sources to reach insights that we might recognize as epidemiological?
Wow, what a great question, and well informed one too. And there's a few pieces there. One is that in the 430 in Athens, which is a major city in classical Greece, in the context of a big war with Sparta, it's a famous war. There's a major outbreak of an infectious disease that's described by, of course, one of the classic Greek historians who's writing about the war, and ups to write about this plague of Athens as we know it, Thucydides. Thucydides is canonized as one of the great historians, and so everybody's who's writing about plagues after Thucydides knows Thucydides. This is one of the really annoying things, is that they're all sort of in conversation with this other ancient historian. So there is, in some sense, an ongoing conversation about infectious diseases in both Greek and Latin. But I would also say too that this doesn't always mean that our ancient sources are sort of slavish imitators of Thucydides. There must have been, in fact, we have a source that makes fun of the slavish imitators of Thucydides. But people like Procopius knew Thucydides well, and when he's writing his plague passage, he seems to have brushed up and read his Thucydides so that he knew what Thucydides had said, but he's not, copying Thucydides. And when he wants to observe a difference, he's not afraid to observe something different. And I think very much the same for Galen, who's very aware of the existing Greek medical tradition on epidemics, which means something a little bit different in classical Greek medicine, but he's aware of the whole discussion of diseases going back to Hippocrates, and he is absolutely nobody's follower. He is not afraid to make a different hypothesis. He has huge respect for predecessors like Hippocrates, but when he makes different observations, he reports them. So in that sense, he's a good scientist. So there are these ongoing conversations already in classical antiquity, where even across hundreds of years, they're aware of this ongoing conversation. But in my thinking, they're mostly willing to make observations that depart from their models when they feel like they need to. Now, did they have epidemiological thinking? No, it's a tricky question, because it involves a number of tricky questions. You have to start with the fact that they didn't know that diseases were caused by germs. They thought of disease as a breakdown of the body's balance of the four humors that comprised the body, and that in times of health were kept in balance. So they could clearly observe that sometimes whole populations of people would get sick at the same time. I mean, they if you have eyes, you can see these people are getting sick all at the same time. And they usually think of that as caused by some kind of disturbance of the atmosphere, pollution or miasma, that's causing a whole group of people to fall sick at once. What's interesting is that the Greek medical tradition really doesn't, with a couple of marginal exceptions, think in terms of contagion. They really stick to the dogma of humoral explanations of disease. And so they never really admit that epidemics are really driven by contagion. And in a sense, that's a kind of extraordinary stubbornness, because other lay people seem clearly to have recognized the importance of contagion in epidemic outbreaks. And you know, I think of the veterinary medical traditions. We have a lot of texts about horse medicine from classical antiquity, because horses are amazing, but they're also expensive, and the rich people who own them want to know how to keep them well. And the veterinary texts are very clear that, you know, if an animal gets sick, separate it from the other animals. In other words, diseases are contagious. But there's something really hidebound and stubborn about the medical tradition on this issue, which is very reluctant to think about contagion. So that ultimately ends up being a really important roadblock to productive thinking about population health in times of epidemic disease.
All right, thank you. So moving on to our next question. In Ottawa, we've been reflecting lately on whether the pathogen, disease, or various large-scale social responses that matter the most in making one feel a pandemic or having a pandemic experience. Do you have any comments on debates about etiology, political responses to pandemics, or pandemic management in antiquity?
Oh, wait, is this about antiquity or current times?
I think it's about antiquity
Okay,
in
good.
relation to comments in the modern period.
Yeah. And I mean, you know, I have thoughts like any other citizen about the confrontation of this pandemic, but it's another way in which it can cause us to look back to the past and even ask these questions about things like pandemic management, because that's clearly anachronistic. And sometimes it's really good to ask anachronistic questions, because it can help you see things that you might not have seen, but you also have to be careful, and you have to look for it outside of the terms we use. And so there's nothing like pandemic management in ancient sources. And I would say there's still a lot to be learned, but it strikes me that one of the notable differences, even between the late ancient, so the plague of Justinian and subsequent outbreaks, and late medieval and early modern experience with plague, so the Black Death and the aftermath, is really the political response. And so you have to look very, very hard to find anything that would qualify as public health in late antiquity and the early Middle Ages. That's not to say it doesn't exist. There's an overlooked source that implies a kind of primitive version of quarantine before the, you know, without using that word, but understands you have to shut down trading connections in the time of an outbreak to stop disease from moving from one city to another. That's a 7th century text that Mike McCormick in his article in Speculum, if there's any specialists interested, refers to, but nobody's ever really heretofore noticed. So that's interesting too, because it implies that the thinking behind quarantine was sort of organic and wasn't just completely discovered in the late Middle Ages. But the bigger point probably is you have to look really hard to find public health response that's not really fundamentally religious. So what people seem to do in late antiquity, we would categorize as religious, and specifically these kind of liturgical, large-scale rituals that mobilize populations to pray. And that seems to be the main collective response to the pandemics. What you don't find is a lot of evidence for the kinds of things you find in the late Middle Ages. What do you find in the late Middle Ages? Quarantine, massive apparatus of quarantine that recognizes that plague spreads and that you can stop it. They don't even know about the microbe yet, so they still don't have germ theory, but they have contagion. And they say you can disrupt the transmission of the plague by stopping it from spreading through, for instance, traders. You have the development of ever more sophisticated public health boards, and this actually even precedes the Black Death, but public health boards that are empowered to take action, and that start doing things as well, like tracking mortality that lets them even perceive when plagues are starting. And then ultimately things like that really are very little different from what we call lockdown. You see all of that develop in late medieval and early modern times. And what's interesting is in antiquity, you don't see that style of pandemic management. So it's a good question, but I think the answer is actually, interestingly and significantly, that we really can't find pandemic management of that sort in antiquity.
Thank you. Our next question asks whether we know anything about how the Antonine Plague manifested that might suggest what type of disease it was.
Well, yeah, that's a big question. I moved quickly over that, partly because we don't know. And so I can give a slightly longer answer of why we don't know. First of all, it's always very difficult to take any written account of a disease by a pre-modern author and to diagnose it. We call this retrospective diagnosis, in our terms, as being a disease caused by a specific microbe. That's hard to do for a lot of reasons. They don't have germ theory. So they are looking at a welter of diseases and maybe not thinking of a specific disease causing in specific people. They don't have our scientific categories. Not all of the texts we have are written by medical writers. So there's lots of reasons why it's really, really hard. Bubonic plague is an interesting example and somewhat of an exception, because bubonic plague is fairly clinically distinct in the bubonic course, that is characterized by these large, hard, painful swellings called buboes, these sacs of pus that extrude from the infected lymph node. That's a pretty weird symptom. And when it's associated with mass mortality, it's a pretty good indicator of bubonic plague. But even in the case of bubonic plague, which is pretty clear from written accounts, until we had the DNA, there were serious scholars who questioned whether in both the first and particularly the second pandemic and Black Death, whether that was really the disease that was being described and that bacterium caused it. And I mean, people, as late as the mid 2000s were confidently saying this could be anything except bubonic plague. Rarely can historians be proven so absolutely wrong. And they just were proven absolutely wrong. The plague's DNA, Yercinia Pestis DNA, has been repeatedly and very, very confidently recovered from Black Death and first pandemic victims as well. So that's wonderful when it happens. This is still a new science. The first complete ancient genome wasn't sequenced until 2011. This is all happening now and very, very fast. And plague is the disease that we know the most about from ancient DNA, because it's it's a pretty big bacterium with a lot of DNA, and it killed a lot of people, and people are looking for it. But we don't know about a lot of other diseases. And so far we don't know from DNA evidence what caused the Antonine Plague. So all we have are written sources, and above all, the Dr. Galen, who lived through it and describes it in a couple of different passages. And he seems to describe kind of extrusive black pustules that rise above the skin over most of the body. And there's not that many diseases that are even in that ballpark. That sounds mostly like smallpox. He describes a kind of black stool. So this is probably people who are internally hemorrhaging and are bleeding in their waste matter, as well as what sounds like ulcerations in the throat. So again, kind of maybe hemorrhaging internal. That's very little to go on. It's why most people who've looked at it, who've been willing to guess, have said smallpox or some kind of smallpox. The problem is had a few more studies, or at least two big studies, that have found historical smallpox DNA. And one thing we've learned is that modern smallpox, the viral disease caused by the virus variola major, is only 400 or 500 years old. So the branch of the viral family that causes all modern smallpox is very, very virulent. It's a nasty disease. It's one of the worst diseases in history. It's only 400 or 500 years old. So we know now that the Antonine Plague wasn't smallpox in a real simple way. But there has been discovered from the 8th, 9th century on an ancestral form of smallpox, so a close relative from an extinct lineage of the same family, orthopox viruses. It's between the animal diseases we know of and very similar to smallpox, but definitely not identical. So it's why I would now say that the Antonine Plague was maybe ancestral smallpox. That's way less decisive. And ultimately, the only hope is that we're able somehow to recover diagnostic biomolecules. So whether DNA or some other biomolecule associated with the pathogen from skeletons, and people are looking. And so far, no go. One of the problems is that smallpox is a virus, so it's smaller than a bacterium, doesn't have much DNA, but smallpox is a DNA virus. So there's hope that old smallpox could be found. A lot of viral diseases are RNA viruses, including COVID-19, measles. If it was an RNA virus, it's less genetic material and it's very, very fragile. And unfortunately, we may never get it and we may never know. So this is a very active area, and hopefully we learn more. But for now, if you made me bet, I'd say maybe ancestral smallpox.
Thank you. Moving on to the next question. We do have about 3, so we've
Okay, I'll
got
talk
5 minutes
fast.
left.
Okay.
If we can impose on you to stay for a few minutes longer, we only have 3
I'm happy to,
more
but
questions. So the first is the plague under Leo in 729 that is key to iconoclasm and extension of the Justinianic Plague?
I haven't got that far. We need to look at these later outbreaks that have been kind of neglected. I really don't remember off the top of my head. I wanted to say that that when we know there's a big outbreak of bubonic plague that hits Byzantium in the 740s, but I can't remember if that slightly earlier one is thought to be or not. The place to look and where I'll go and refresh myself is the really enduringly valuable catalog that Dionysius Stathoulopoulos created called Famine and Pestilence in early Byzantium. That is a really wonderful, careful catalog of all this evidence for plague and other epidemic outbreaks, and it'll provide some basic notes there. It'd be worth looking at. But off the top of my head, I don't remember more details.
Thank you. The next one is, do you see any historical evidence of blaming a subgroup, that is the other, for causing plagues, as some in the US blame China or pharmaceutical companies for COVID-19?
Well, I think it's one of the really predictable, unfortunately, and enduring patterns of the human response to pandemic mortality. Pandemics are traumatic. They cause suffering. They cause death. They often are difficult to explain, and so they cause pain and suffering and death in ways that are often very difficult to explain completely, even with our modern scientific knowledge. And they have very unequal impacts, and so that is a fertile ground for different dark sides of human psychology to flourish, unfortunately. And so different kinds of prejudice, discrimination, hatred, and particularly persecution of outgroups or minorities finds fertile fields in the outbreaks of pandemics. The So it's historically, you know, a recurrent thread that has manifested in different places many times, but not always identically. And I would observe that I think one of the things that pestilence or epidemics do is they activate pre-existing forms of discrimination. So, you know, anti-Asian hatred didn't start in 2020. It was amplified by the pandemic. You know, anti-Semitism in the Black Death wasn't invented in the 1340s. It was empowered. It was given fuel. So it, you know, it's a complicated phenomenon. The disease outbreak doesn't cause persecution, but it sort of gives the opportunity for people to exploit fear when things are unknown. And so I think that's an important pattern that we can learn from. And you know, the only way to kind of escape or change some of these patterns, because they're not inevitable, is to know that history and to expect and prepare and counteract when we do face pandemics, something that's unfortunately kind of predictable.
All right, we had one other question come in over this time, so I'm going to ask if you would mind answering both, since we are just
Sure.
about at 5:30. So the question was, why doesn't the plague spread more widely now when there's still interaction between humans and animals such as rats?
So plague is a disease we'll never get rid of, because it's always going to live in animal populations, and it still exists in animal populations in what's probably its most ancient homeland of the Central Asian steppe and abutting regions. And then other places where it has dispersed historically, from Madagascar, where it's still enzootic and frequently causes human disease, to the American Southwest. And so in the third pandemic that spreads from Hong Kong in 1894 and transmits globally, there's a massive effort to control it. And in Europe and the US, it's kept from becoming a catastrophe. It kills a ton of people in East and South Asia, and to some extent in Africa. But it does get to the US, and it seeds rodent populations. And so, you know, if you're in the American West, prairie dog populations have enzootic or permanently established plague. So don't eat prairie dogs. I would recommend, in general, being careful eating any kind of wild rodent. People do still eat marmots in Central Asia, Mongolia, and they get plague. So plague is still causing human disease, but it doesn't cause the kind of massive outbreaks for lots of reasons. I mean, it apparently is a disease whose transmission we can disrupt. There have been massive efforts to eliminate and control rodent populations. I think it's, you know, there's still a lot of rats in big cities, but nothing like there were in the past. And so the ability to disrupt the transmission of the disease in these commensal rodent populations seems to be the single biggest difference. But it really starts with the fact that we understand the plague. And even in the third pandemic in the 1890s, there was a pretty massive effort to disrupt the transmission, particularly across oceans, by, you know, fumigating ships to kill all the rodents. And so plague lurks out there. Another reason why it doesn't cause huge numbers of death in humans is that it's treatable with antibiotics. But yeah, it's scary to reflect on the fact that it's one of those diseases that was so terrible in our past, and is not only still out there, but will always be out there, because as long as there's wild rodents, there's probably going to be plague.
Thank you. And our last question asks, what is the basis for scholars who claim the low estimate of approximately 2% for the death rate in the Antonine Plague, especially considering that it probably killed Lucius Verus, several of his generals, and Marcus Aurelius?
Yeah, I mean, so You're asking the wrong person. I don't know how you could really credibly think it was so low. And I come at that question from the perspective of we can learn so much from comparative demography. So in highly developed societies today, where most people live long lives, where infectious diseases don't kill people, a little under 1% of the population dies every year. In pre-industrial societies, most cases, probably 3% of the population dies every year. So we know that in Italy, times when we have very good government documents, 3.5% of the population dies every year, like not in plague years, just in good times. So I think the first thing to learn about estimates of the mortality of the Antonine Plague at 2% is that some people don't have the perspective of what pre-industrial societies are like demographically. It would require that the year the Antonine Plague struck was the healthiest year we know about in the history of pre-industrial times. So I think it disqualifies it from being worth taken seriously. It's based on good faith efforts to understand very, very difficult source records. The fact is there's nothing that really tells us. And so everybody's kind of trying to come up with models and estimates. I think comparative demography can be a really important and powerful tool. And it's ultimately why, one of the best things we can maybe do in the Antonine Plague is say, is it like an ordinary year when like 3% of the population dies? Is it like a crisis year from these other episodes that are known when there were really terrible influenzas or smallpox or typhus outbreaks? Or is it like the Black Death that kills, 40-50% of the population? I tend to think that it's not like one of those that kills, a quarter to half the population. But we don't know. That could be wrong. I think we do know that it didn't kill 2% of the population. I think that's not a reasonable inference from the sources we have. But the estimates are going to be really wide because we don't really know, did it get into all the villages where most people lived in a very rural society? So there's wide boundaries on what's possible, but I don't think it goes to those really, really low estimates. I mean, I think it's hard to imagine that it wasn't at minimum 2 to 3 times the normal death rate, given that we all of a sudden have so many people telling us, and that we have so many proxy sources that say something really big changes. And it doesn't just have to be disease, but the sources say that was a major, major factor. I think that leaves you with a minimum estimate somewhere around what I've said. And if people wanted to argue higher, I think that's not unreasonable. They just have to explain, how did the disease really get into a lot of these places where we just don't have evidence, and we don't really know if it killed a ton of people.
Well, thank you so much, both for your lecture, for staying over time. I believe that the format of this Zoom call means that we can't join us in our little virtual applauses.
Thank you,
but I hope that you hear our appreciation from the words and the questions that you've received this evening.
Yes, thank you for the very stimulating questions.
Thank you so much for a very stimulating lecture and for your virtual visit to Carleton.
Thanks for virtually having me.
Good night, everybody.